Hello, I'm Sung Joon Kim, in charge of radiology at Gangnam Severance Hospital in radiology class. We will specify the angle for flat feet evaluation. And today I would like to introduce the technology of the automated tool. We have completed the patent registration in last May. I am preparing to publish the clinical verification results as research papers. This technology is based on deep learning technology and artificial intelligence technology, and before I explain the technology, I would like to present briefly about the current state of imaging artificial intelligence. I guess then you've heard a lot about the medical application of deep learning-based technologies through various media, looking at the recent status of FDA approval in the United States. Indirectly, I would like to introduce you that you can see how much it is becoming a propagation. The shown screen is a website run by the American Society of Radiology and is one of various dashboards run by the website. It shows the updated artificial intelligence technologies related to radiology approved by the US FDA. This is captured by me about 2 months ago, and you can see the classification of the approved product name, the company, what subspecialty is covered, what modality target. I counted the numbers per each section, and nervous system radiology is overwhelming. My musculoskeletal specialized area is about 11. 6 of these 11 are tools that detect fractures are the majority, and you can see that the rest of the various applications have been sporadically approved. The clips you see are those that our lab is developing. It's similar to those approved by the FDA, so everyone has similar ideas, and I think the basic point of the fight is the speed or the satisfaction of users. Going into the technical explanation in earnest, flat feet are known to have a bad effect on foot health. You can easily lose balance and get hurt, make your feet tired easily, cause the degenerative changes in the tendons, and these are bad inducers. Therefore, as you know much, it is one of the military service exemption standards, and you are looking at articles related to the Ministry of National Defense. And it supposes to decide whether to be exempt from military service by standards setting. Until last year, military exemptions were allowed to be over 19 degrees, but from this year, data show that it has been strengthened to over 16 degrees. And even with such a small difference, military exemptions are determined. That's why test reliability is very important, and there are many key factors that determine the reliability of the test. But more important than anything else is reproducibility, which means that there should be no different results every time you measure it. If each doctor continues to produce the different values, we can think about whether these numbers make sense for patients or those who go to the military. And the MIRI angle is the most commonly used X-ray imaging method and adapted it as a military exemption standard. It is a measurement method how much the front of the talus is inclined toward the soles of the feet, and there are quite a few ways to measure this angle. But it is difficult to say that it is actually standardized. Even within one method, if you look at several research papers, you can see that there are some differences of coincidence each measurers and among measurers. As my personal opinion, I think it will be worse than this in the actual medical situation. Since the major axis of the talus and the first metatarsal bone must be defined in our research and development, the major axis of the talus is the center of the middle part of the talus, and the connecting line between the navicular and the major axis of the talus joint, and the long axis of the first metatarsal was taken as a connecting line the proximal and distal centers of the first metatarsal bone. If the angle between the two lines is opened upward, it is determined as a positive plus flat foot, and on the contrary, if it is opened downward, it is defined as a negative minus angle and determined as a PES covus. In order to automatically find the major axis of bone, we decided to develop an algorithm to remove bones first, and the network used in this development often uses UNet. And we applied SegNet for various reasons, and in order to secure the diversity, images taken over a year were randomly selected, and 300 pieces of data were used, excluding images with very low quality or surgical instruments. Segmentation consists of two steps. As the first, a low-resolution image is used to form a box around the location of the skeleton and the first mesenchymal bone, and inside the box, a semantic segmentation of the skeleton boundary and the first mesenchymal bone is used. From the algorithm, the bone boundary and the first mesenchymal bone was sketched and compared to ground truth. The algorithm with a y-escent of about each 93% of the bone and mesenchymal bone was developed, and the extracted segmentation mask was used to define the long axis. As you can see, when the major axis is found in the major and mesenchymal bones, a tool was created to measure the flat foot angle based on the algorithm developed, and it was prepared for clinical use. Once you insert the image and press the extraction button, landmarks marking of the long axis are automatically displayed. If landmark doesn't like it, it made possible to move it, and it was verified this tool is two ways, one of which matches the level of people who can basically be called experts to measure this tool. We made two experienced references first, and measured it once, and measured it without it a week later to test whether reproducibility increases when AI is used. Statistically, as you all know, ICC was used to measure the consistency of continuous value. The results show that the degree of agreement has improved significantly compared to with AI, showing statistically significant differences. I saw how consistent it was with the answer, and you can also see that both the less experienced measures of reader 1 and reader to paid close to reference standard when they used AI. Currently, there are many other flat foot angles, one of which is calcaneal pitch, which has been developed and completed by the automation tools development. And now we'd have the opportunity to verify them through other institute images based on the developed tools. It's a simple technology, so that's all I have to say. And in addition to the technology mentioned, our lab has patented various automation technologies related to deep learning-based fracture detection, image generation, and various measurements using X-ray. I would like you to pay a lot of attention to these other tools. Thank you for your attention.